Hello everyone. Today we will be doing the math section module 1 of the digital SAT practice test number 1, and we will be doing questions 24 through 27. So first looking at question 24, for line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating line H down 5 units in the xy plane. What is the x-intercept of line K? So first, let's find the equation for line H, and then we can focus on finding line K afterwards. So this information is all for line H, and we can solve for the slope first. So we know that slope is equal to y2 minus y1 over x2 minus x1. And in this case, we can say that's x1 and y1, x2, y2. So this is equal to 160 minus 130 over 23 minus 18. And that means that our slope is equal to 30 over 5, which is equal to 6. And I think it'll be easiest to use the form y equals mx plus b in this case. So we know that m is equal to 6 because we just solved for the slope. And then we'll keep plus b, and we can solve for b by using our point. Let's use our first point, 18, 130. So if we plug in y equals 130, and that's equal to 6 times 18 plus b, well, 6 times 18, we can do that out, and we get that's equal to 108. So 130 equals 108 plus b, and that means that b is equal to 22. So then we can plug that in. So we'll have that line H is represented by the form y equals 6x plus 22. But remember, we want to focus on line K now. So line K results from translating line H down 5 units. So if we want the line to go down 5 units, we can just subtract 5 from the y-intercept. So that means we can actually just subtract 5 from 22. And that means that line K is equal to y equals 6x plus 17. And if you don't really understand that, you can always graph these, or at least have a rough version of the graph. Because if we had line H right here with an y-intercept of 22, and we wanted to shift it down 5 units, we'd have the same slope because they're parallel. And then this distance right here is 5. So then 22 minus 5 is 17 for the y-intercept right there. And we want to find the x-intercept of line K. So the x-intercept is when y is equal to 0. So we can set 0 is equal to 6x plus 17, then subtract 17 on both sides, and you get that negative 17 is equal to 6x divided by 6 on both sides. You get that x is equal to negative 17 divided by 6. And that is equal to option D. Moving on to question 25. In the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c? So first, let's think about our different graphs. If they intersect at exactly 1 point, first we can represent the intersection as when the two expressions for y are equal. And then we can actually just subtract the c over. So negative x squared plus 9x minus 100 minus c equals 0. And this represents a quadratic equation. And we know that if there's exactly 1 point, that means there's exactly one solution. And in that case, if you know that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a, we know that this value right here, the b squared minus 4ac, equals 0 when we have exactly one root. So in this case, we have that a equals negative 1 because that's the coefficient right here, b equals 9. and make sure that we're looking at our new equation. A is equal to -1, B is equal to +9, and C, in this case, it's a different C, but you understand that it's whatever the constant is. So in that case, that's -100 minus C. We'll just call this C1, I guess, to avoid any complications. So then we have that B squared, so 9 squared minus 4 times -1 times -100 minus C is equal to 0. So 9 squared is equal to 81. And then you want to, if we have a negative here, and then we have some negatives here, we can multiply them out to make it positive. So -4 times 100 plus C, and that's equal to 0. Then we can distribute the 4. 81 minus 400 minus 4C is equal to 0. And then we can add 4C to both sides. We're almost done. 81 minus 400 is equal to 4C. And then now we just have to solve for this. So solving, we get -319 equals 4C. So C is equal to -319 divided by 4. And looking at our answer choices, remember we're looking for the value of C. We get that, that's option C. Moving on to question 26. For each real number R, which of the following points lies on the graph of each equation in the xy plane for the given system? So we see that we're given two equations right here, and we want to find which of the following points lies on the graph. So there are different ways of doing this. You could just plug in the points and see which one works, but in this case, I think it might be easier to work with this system and simplify it, and then you can plug in the points. So in this case, if we multiply by the first equation by 5, we get that's 10x plus 15y equals 35. And we notice that that's actually identical to the second expression, which means that this is like the only information we have, and there's no need to plug it in to both equations because they're the same, they're equivalent. So now that we know that, we can just focus on the first one because that has smaller coefficients that might be easier to work with. We can plug in our options to 2x plus 3y is equal to 7. So if we try part A, we get 2r over 5 plus 14 minus 3r over 5 minus 105 equals 7. So just looking at that, we know that 14 minus 105 is going to be a pretty large negative number. And we'll also be left over with negative r over 5, but we don't really know what r is. And in this case, we want this to be true for each real number r, which means that we want our r's to cancel out. So then we can try, we know that A doesn't work, we can try option B, 2 times negative 3r over 2. And in this case, let's just focus on the r's because we know that we want them to cancel out. So 2 times negative 3r over 2 plus 3 times r. Okay, so we know that the r's would cancel out. Now let's keep in mind the original plus 7/2. So 2 times negative 3r over 2 plus 7/2 plus 3r is equal to 7. So that's negative 3r plus 7 plus 3r is equal to 7. So the negative 3r and the 3r cancel out. And then we get 7 equals 7, which is always true. So that means our answer is choice B. Okay, so for the final question, question 27, we have the perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k square root of 3 centimeters, where k is a constant. What is the value of k? So first, let's draw an equilateral triangle here where each side is equal to s because all of the sides are equal. That's what equilateral means. So we know that the perimeter is equal to 3s, and that's equal to 624. So if we divide by 3 on both sides, we get that s is equal to 208. So we want the height, so we can replace all these s's with 208. And then let's draw a line that's perpendicular to the base, and that's going to split our base into two. So we have 104 on either side because this is the midpoint. And it's important to note that because we have an equilateral triangle, each of these original angles is 60 degrees. So because we know that this is 90 degrees and this is 60 degrees, then the sum of the angles in the triangle add to 180 degrees. So we know that this angle right here is 30 degrees. And that makes sense because this line right here splits this angle into two equal angles. So that means that we have a 30, 60, 90 triangle. And we know that when we have a 30, 60, 90 triangle, that the side opposite to 30 degrees might be x, 60 degrees is x root 3, and then 90 degrees is 2x because we have that 1 to root 3 to 2 ratio. So in this case, we have that x is equal to 104, and we want to find the height, which is x root 3. So x root 3 is just equal to 104 root 3. And this is equal to k root 3. So we can cancel out the root 3's and we get that k is equal to 104. If you liked the video, make sure to drop a like down below and subscribe.